Great Masters Vessel Classical Academy students, good afternoon. You are welcome to another session of chemistry. Today we are going to the last two sessions. We are revising the last second theme examination, but today we are going to discuss hydrogen. We are going to discuss hydrogen. Like I said, like I've always said, anything we are teaching you now is for SS1, SS2, SS3. Because what you have in your WAEC examination is between 40 to 50% SS1 work. Therefore, whatever we are teaching now is both for SS1, SS2, and SS3. We're going to discuss hydrogen. And we're going to, the outline is occurrence. Occurrence of hydrogen, electronic configuration, of hydrogen, laboratory preparation of hydrogen, industrial preparation of hydrogen, activity series based on hydrogen, properties of hydrogen, uses of hydrogen, uses of hydrogen. Let me stop at this because we may not even be able to finish up to the outline that I've given you. The first thing we should know is where hydrogen occurs. Hydrogen occurs in the atmosphere. It occurs up to about 0.01% in the atmosphere. Then hydrogen also can be found in combined state. For instance, you know that water contains hydrogen. One molecule of water contains 2 atoms of hydrogen and 1 atom of oxygen. And 1 atom of oxygen. Hydrogen can be found in most of the organic compounds, especially when you talk about carbohydrates. Carbohydrates are those organic compounds that contain carbon, hydrogen, and oxygen. Hydrogen is equally found in protein. Hydrogen can equally be found in fats. Therefore, these are where you can find hydrogen, but they are in combined state. That takes care of occurrence. Then we'll look at the electronic configuration of hydrogen. We know that hydrogen is the lightest element and the lightest gas that exists. Being the lightest element, that is why you find hydrogen first in the periodic table, and it's in group 1. Because hydrogen is in group 1 and is the lightest element, you will find out that the number of protons in hydrogen is 1. Because the number of protons is 1, you see the atomic number being 1. Therefore, hydrogen, if we are to write the electronic configuration of hydrogen in diagrammatic form, it has K shell with 1 electron. And if we are writing the electronic configuration in terms of shell filling method, you see it to be 1. This is a diagrammatic diagram. This is shell configuration. If we are writing it in SPD notation, it becomes 1s1, meaning that in the s orbital you have only 1 electron. Therefore, you see that hydrogen belongs to group 1. Hydrogen belongs to group 1 because it has only 1 electron in the outermost shell. But it doesn't behave like other elements in group 1. Group 1 elements are called alkali metal. Alkali metal. But you can see that hydrogen is not a metal. But hydrogen is only in the group 1 because it has 1 electron in the outermost shell. Hydrogen has some chemical properties similar to group 1 elements. But there are so many other chemical properties where hydrogen does not resemble group 1 elements. But the most important thing is that hydrogen is in group 1 because it has 1 electron in the outermost shell. You can see that we have discussed about occurrence, we have discussed about electron configuration. The next one we are going to discuss is laboratory preparation. How do we prepare hydrogen in the laboratory? There are many methods of producing hydrogen in the laboratory. Some of them are 1. Addition of dilute acid on certain metal. You can produce hydrogen if you add metal that is above hydrogen in the electrochemical series or in the activities series. Any metal that is above hydrogen, if you add dilute acid to it, it will liberate hydrogen. For example, zinc. Zinc is above hydrogen in the electrochemical series. Therefore, if zinc reacts with dilute hydrochloric acid, you have zinc chloride, aqueous, plus hydrogen gas. Students, is this equation balanced? Is this equation balanced? When you look at this equation, you see that it's not balanced. And what you do when you want to balance this equation is to balance it by adjustment in the coefficient of the compounds. You will not do anything to affect the formulas that I have written, because the formulas I have written is the correct formulas of the compounds and elements. If you look at here, you see that you have hydrogen, 2 atoms of hydrogen. Therefore, what you do now, you put 2 here to make it 2 moles of hydrochloric acid. When you look at this equation now, you see that it is balanced. Zinc is 1 atom here, zinc is 1 atom. Chlorine is 2 atoms here, chlorine is 2 atoms. Hydrogen is 2 atoms here, hydrogen is 2 atoms. You can see that you have produced hydrogen by this reaction. For this number 1 method of producing hydrogen in the laboratory. Then we'll look at the second method, is addition of some metals on cold water. Addition of some metals on cold water. Note the plus. Some metals, which means it's not all metals that when you add it in cold water that it will produce hydrogen. If you look at the activity series, you see that the activity series, you have potassium, sodium, calcium, magnesium, and so on as it goes down. As you go down this group, reactivity decreases. Therefore, these two metals, potassium and sodium, you can put in bracket here, potassium and sodium. If you add potassium and sodium in a dilute acid, it will liberate hydrogen gas. Let us look at the equation. Students, look at this equation and see whether it is balanced. The first thing you do when you are writing equation is to write the element and compound as they are reacting, their actual formulas, and then the product. After writing it, you now check whether the equation is balanced. If you look at this equation here, you see that sodium is 1 atom, sodium here is 1 atom. Hydrogen is 2 atoms, hydrogen is 1 plus this to make it 3. Therefore, it's not balanced. For what you do, you put 2 here. If you put 2 here, you see that you have hydrogen now, 4 atoms. Oxygen, 2 atoms. For if I put 2 here, you see that in my balancing the equation, I didn't alter the equations of the compounds and the elements that make up the compound. Therefore, you see here now you have 2 atoms of hydrogen, 2 atoms of hydrogen, sorry, 2 times 2 to give you 4 atoms of hydrogen. Here you have 2 times this will give you 2 atoms of hydrogen plus another 2 here, making it 4. For the hydrogen is balanced. The next one is oxygen. Oxygen 2 times 1 give you 2 atoms. 2 times 1 for this equation is balanced. You can see that hydrogen gas is formed. Is that clear? All right. You can see how you have produced hydrogen here. You have seen how you have produced hydrogen here. Then the third method, laboratory method, is action of some metal on caustic alkalis. These caustic alkalis are things like potassium hydroxide and sodium hydroxide. Action of some metals, and when we say some metals, they are actually metals that can react with acid and base. And such metals are aluminum, tin, and aluminum, tin, etc. Can look at some of them. Therefore, when this metal will write an equation, for instance, you have sodium hydroxide, aqueous. If it reacts with aluminum, that equation is sodium hydroxide aqueous plus ALS to give you NaAlO2 plus H2 gas. For let's look at this. This one is +1, this one is +3, this one is -2 times 2. Therefore, +4 minus 4 will give you 0. Therefore, you have hydrogen. You have hydrogen 2 here. The best thing is to put 2 here too. Therefore, this one will be 2. That will make hydrogen to be 2. Therefore, this is the equation. You have produced hydrogen here. Well, we'll go to the last one, action of steam on some metals. Action of steam on some metals. Remember in this preparation, the first one we said action of dilute acid on certain metal. Those certain metals are sodium and potassium. Then we talked about action of some metals on cold water. We talk about action of some metal with caustic alkalis, and we have mentioned aluminium reacting with sodium. Then the next one is action of some metal on steam. Action of some metal on steam. That is the fourth one. Some metal. Therefore, the metals that will react with steam to give you hydrogen are magnesium, and iron. Magnesium and iron. You have Mgs reacting with steam, H2O gas, to give you MgO solid plus hydrogen gas. You can see that hydrogen is produced in this reaction. We look at iron reacting with steam. It will give you Fe2O3, iron 2, iron 3 oxide plus hydrogen gas. Therefore, you look at how you can balance this equation. This is the formula. The correct formula is this. For you to balance the equation, you can see that oxygen here is 3. Therefore, if you put 3 here, you have balanced oxygen. For we now look at hydrogen, you see that hydrogen is 6 here. For if you put 3 here, you have balanced hydrogen. For you can see with these two methods, you can equally produce hydrogen. But note that it is not all metals. If you check in the activity series, you see that they are the metals that are not highly reactive, but they are reactive. The reactive elements there are potassium and sodium. For when you begin to go down into the activity series, it's becoming less reactive. For those ones that will react with steam are magnesium and iron. That's about laboratory preparation. Let's look at how we can prepare it industrially. There is something you will notice when you talk about laboratory preparation and you talk about industrial preparation. Laboratory preparation is just the one you can do in the lab. The conditions in the lab will make it possible for you to produce it. But industrial preparation takes into consideration cost. The one you do in the laboratory may be very costly, but because you are producing in small quantity and you are producing for learning, it's not to make profit. Therefore, when you are doing it industrially, you have to ask yourself, this hydrogen that I'm going to produce, how much am I going to sell it? Therefore, when we talk about industrial preparation, is sometimes different from what you do in the laboratory. For let's look at how you can produce it industrially, because the hydrogen is very important. For some of you who are in SS3, you know some of the uses of hydrogen. For some of you who are not yet there, you will still learn it maybe in the next lesson, because we need to talk about uses of hydrogen. Some of the simple uses of hydrogen is that most of you take butter and margarine. Most of you take margarine. The margarine you are taking, they use, is made from oil, and is hydrogen that is used for the hardening of the oil. All right, let's look at industrial preparation of hydrogen. The first one is action of steam on coke. Coke is a type of carbon. Coke is a type of carbon. Steam, you know what it is. Therefore, this process of producing hydrogen from coke, you will first produce water gas. After producing water gas, you will now react water gas with excess steam. From the excess steam, you can now produce your CO2. After producing a mixture of CO2 and hydrogen, you will pass the solution or the gas. You pass the gas through an alkali. The alkali will absorb the CO2, while hydrogen will not react with it. You can now recover your hydrogen. Therefore, this reaction is this. You have your coke plus steam. You have CO gas plus hydrogen gas. This is a mixture called water gas. This is a mixture called water gas. Then what you will now do, this water gas, CO, G plus H2 gas plus steam. That will give you CO2 plus well, you have produced your hydrogen gas. And if you pass this mixture of gases into an alkali is KOH or NaOH, potassium hydroxide or sodium hydroxide. The potassium hydroxide or sodium hydroxide will absorb the CO2, and then hydrogen will be recovered. Then the next one is, and this process, we'll call this process Bosch process. There's something all right, let me leave it when I'll explain the next method. I'll mention it. Because you will see that water gas contains CO2 and hydrogen gas. You still have what we call synthesis gas. It contains carbon 2 oxide and hydrogen. But the difference is that in synthesis gas, you have 3 moles of hydrogen. This one is 1:1. But that of synthesis gas is 1:3. That is 1 mole is to 1 mole. But in synthesis gas is 1 mole is to 3 moles. When we go to the next method, you will see synthesis gas. Number 2 method of producing hydrogen is by action of steam on hydrocarbon. By action of steam on hydrocarbon. Action of steam on hydrocarbon. For some of you who are in SS3, you know what hydrocarbon, but let me just explain what hydrocarbon is. Hydrocarbon is an organic compound containing carbon and hydrogen only. And in the hydrocarbon, you have the alkane, the alkene, and the alkynes. Let me just use a simple alkane as an example. Methane. Methane is CH4. If it reacts with steam, This is a gas. If it reacts with steam, it gives you CO gas plus hydrogen gas. This one is called synthesis gas. They may ask you, what is the difference between water gas and synthesis gas? You will just say that both, all right, similarity is that both of them contain carbon 2 oxide and hydrogen. And the difference is that synthesis gas contain 3 moles of hydrogen, while water gas contain 1 mole of hydrogen with 1 mole of carbon 2 oxide. They can ask you what is the difference between synthesis gas and water gas. Therefore, you can see that we have not produced hydrogen. What we produce is synthesis gas. The mixture is combined together. Therefore, the next thing is for us to produce synthesis gas, for us to produce hydrogen gas, we will now pass excess steam into the synthesis gas. CO gas plus 3H2O gas plus steam. Remember that whenever I'm writing steam, I usually put G after water, after H2O. If you just write H2O, it's not representing steam. If you now write H2O, you are referring to water. But if you put the G, it means that you are referring to steam. Therefore, you now have CO2 gas plus 4H2 gas. So you can see how you produce hydrogen from the reaction between hydrocarbon and steam. This reaction occurs at 900 degrees centigrade. Then the third one, the third method is electrolysis. Electrolysis, all right. Electrolysis is the decomposition of a compound. When you decompose a compound, the compound splits into cation and anion. The compound split into cation and anion. Let's take, for instance, sodium chloride. If you split, you have Na plus Cl minus aqueous. Based on this, this is your cation, this is your anion. The cation goes to the cathode, while the anions go to the anode. Therefore, if you want to produce hydrogen, you can produce from electrolysis of HCl. If this thing decomposes, it will give you H plus Cl minus. This one goes to the cathode as hydrogen. This one goes to the anode as chlorine gas. This one is anode. That's how you can produce hydrogen using electrolysis. There are other ones, electrolysis of sodium hydroxide. It will equally give you hydrogen. We are going to stop here. But we will not go until I'll give you some assignments which you can do, which will help you know whether what we have done today. Because if we do a recap, you see that we discussed about occurrence of hydrogen. We talked about electronic configuration of hydrogen. We talked about laboratory preparation, and we discussed about 4 methods of laboratory preparation. We now talked about industrial preparation. Under the industrial preparation, we mentioned 3 methods: action of steam on coke, action of steam on hydrocarbon, and then electrolysis. This is where we are going to stop. Therefore, this is your assignment. One, explain briefly the occurrence of hydrogen. Explain why hydrogen is grouped in group 1 element. 3, mention and explain 3 laboratory methods of preparation of hydrogen. 4, mention and explain 3 industrial methods of producing hydrogen. Let me go through it again so that if you are not seeing the board well, I say that the first one is explain the occurrence of hydrogen. 2, explain why hydrogen is grouped in group 1 element. 3, mention and explain 3 laboratory preparation of hydrogen. Then 4, mention and explain 3 industrial method of preparation of hydrogen. Thank you, great students. I hope you are keeping safe. Bye, and God bless you.